Welcome again to SEG-NAU and Geohorizon Research Community Open Section on how to extract and compare results and ideas from published articles. Yes, so my name is Chinaze Beremiri Arukwe and I will serve as your host for today's webinar. So please, we'd like you to kindly drop your first name and your email address. We could not have you pre-register for this event, so we'd like to have your first name and your email address so that we could communicate with you on our future open sections. That would be interesting as this one too. Thank you. So while we wait for others, you could also tell us where you're joining from. Is yours now. Thank you.
Thank you
So
very
I'll
much.
stop sharing.
Thank you so much for the warm introduction. Can you hear me?
Yes, I can hear you. I'll stop presenting.
Am I audible enough?
Yes.
We can hear you clearly.
Okay. Okay, great. Thank you very much. So thank you very much to the organizers of this session and for your kind invitation. But I would like to start with, for those of us that are Christians, we know that statement, John the Baptist told Jesus Christ, but I'm not worthy to untie the sandals at your feet, of your feet. And that's what I think about when Dr. Vivian, sorry, I like to call her Dr. V, kept saying those very nice words. Dr. Vivian is my senior madam, so thank you very much, Dr. Vivian. But again, I'm not an expert in this field. I'm hoping we'll share a lot of interesting moments this evening. So if you would allow me, I will share my screen right away. Okay. And he's interested in the application of biosurfactants in enhanced oil recovery. This is research interest. However, this is a widely researched area. It's not new, but he wants to know where he can start his own project from. In essence, what will be the novelty of his project? So in his own case, all these interested or needs to identify research or gaps in knowledge in existing work. However, we also have Ezine just close to him, who is also his classmate. In her is what she wants to work on. In fact, she's about to start. But her problem is that she doesn't know what stuff she should use in her project. She's very much confused. That have been reported in literature surfactants. And you see the kind of method, and you find out that it's very interesting compared to what other people are reporting. Probably you'll feel his method is more state of the art. I think that you could actually approach this person for a potential collaboration either to work with his lab or to write up something or probably to interpret a result, as the case may be. When you review literature to compare and extract results, you actually have the tendency to identify potential collaborators. Not to also mention trying to validate your own research results if you already have research results that you want to just compare to what other people have found. This is also one of the essence of reviewing literature. Now, there are different steps involved in reviewing literature. It's starting with identifying what exactly you want to review. Identifying in this case, I would imagine that if you have if you want to go into the, you want to go different databases like Google Scholar, Web of Science, Science Direct, different, any particular database you want to explore. And biosurfactants, oil recovery, you put in your search keywords. I'm sure you would find that you have tons and hundreds of thousands of articles that you would find. The results are usually very, very enormous that you don't even think you can explore all the articles. Of course, you're not even supposed to explore all the articles. That's why you're going to select which of these search results return to you in that particular database or after your search are most important to you. Important to you based on the objectives you've set out to review literature. Also, you have to evaluate each of these articles. Let's say you scale down from 100,000 articles, that 100,000 results you saw, and you decided to scale down to maybe 10,000 or 100, you can now start evaluating each of these articles one by one. And evaluating in this case, I'm talking about extracting, identifying the results they obtained, comparing it to each other and to your own work, if as the case may be, and also synthesizing it, making it is really very important. But then again, one thing you have to notice is that I presented this particular phase or these particular steps in a cyclic manner, which brings us to this point. How can you do this process? This is just to expatiate. One thing I want you to notice is that this is a cyclic manner, which means that it's not a linear, definitely, as we can already imagine. But you start somewhere, and instead of it to end another place, you could actually end in that same place you started from. Now, but the big question is, where do you start from in this process of questions in articles? Actually, because when you want to read an article, if you don't have in mind what these authors wanted to answer or what question these guys wanted to answer, you will get completely lost in information, which we will see shortly too. After identifying the research questions in that particular article, you have to also determine what kind of study they did, what outcomes they measured, extract relevant results, emphasis on relevant, because you could have a myriad of results in a particular publication. Of course, not everything is of interest to you. You have your specific interest, so it's important you identify what is relevant to you in terms of the results. Compare these results, and often one particular step people always ignore is considering the limitations of the limitations identified by the authors in their respective publications. This is something that we often overlook, and we will see shortly why it's important not to overlook this. But where would you start from? Like I said, you could start from anywhere. It depends on your level of, it depends on how familiar you are with this particular topic or with this particular process. It varies from people to people. However, commonly, you will have to start your review process by identifying research questions. This is almost normal. And one thing I need you to keep in mind is, that this whole phase or this whole process of probing literature is never linear. It's always iterative. You start somewhere, you adapt the process to answer your own specific need, or based on how complex you would like to go. So it's a completely iterative process. As you go through the whole cycle, you actually get better at it or not. You may get better at it or not, and adapt it to suit your own specific situation, and also your resources in terms of time, resources in terms of access to publications. But something that is very important is that before you go probing literature, it's important that you have fundamental knowledge of that particular topic. For instance, I can't just go to, I don't just wake up one morning to go and compare results and or maybe works on biosurfactants. When I don't even know what biosurfactants are, I probably don't even know the different types of biosurfactants. It doesn't make any sense. There is nothing you can learn, or there's nothing you can do to compare or to extract if you don't have baseline knowledge of that particular topic. So this is almost a compulsory requirement before you can review literature. Another thing that is very important is you want to extract, you want to compare results. If you're going to compare results A and results B, it is very important that you're open-minded. So you don't have to preempt which one will be better than the other. If you already knew, or if in your mind you already started having, telling yourself that result A should be better than result B, it means that even when you find out that result B is better than result A, you wouldn't know, because you already conditioned your mind with this kind of bias. So it's really very important that you're open-minded before undertaking, this whole process. But let's break it down. Let's break each of these steps down very quickly. So the first one, like I said, is identifying the research questions. Now, research questions I'm referring to here is research questions in the article or the publication that you are looking at to compare either with your own results or with another publication. You have to know what questions these authors wanted to answer. But before you go out to literature, before you go problem literature, it's also very important that you also know what question you want to answer. You know this common thing we were told in physics, scalar and vector quantities. Vector quantities have magnitude, direction, scalar magnitude, no direction. If you don't even know why you want to go probe literature, you are a completely scalar quantity. And be safe to say that you're going to keep wallowing in the milieu or in the forest of hundreds of thousands of publications there without even being specific on what you want. So I will present a scenario. I'm working on biosurfactants. I'm working on rhamnolipids, if you can just imagine that. On rhamnolipids for enhanced oil recovery, or enhanced oil recovery, which I refer to as EOR here in this case. Pardon me, I should have written EOR here. Now, let's say I've gotten some results, right? And I want to compare it to what other authors obtained and see if my results make sense or not. First things first is I have to ask myself, what question do I want to answer before going out to search literature? Whatever question you are formulating has to be specific, it has to be feasible, it has to be testable, and it has to be open-ended. These are very, very key attributes of whatever good research, or key attributes that make a good research question that you have to formulate first of all. Hello? Can you hear me? Hello?
Yeah, we can hear you.
Okay. Thank you very much. First, I heard a beep for a second. I thought I lost everyone there. Okay, so yes. Apologies for the interruption. Okay, so like I was saying, your questions or the question that you have in mind has to be specific, feasible, testable, open-ended. And if you are if the reason you are going to probe literature or to extract and compare results is for you to inform a research project, maybe you want to start out a research project but you don't know where to start from, but you have in mind you have an idea of what you want to research on. You have an original, which in this case, okay, I'm just gonna get my highlighter and my laser pointer. Okay, so your questions in this case has to be relevant and original. But to give you an idea of what is specific and what is not specific, if the question is efficiency in enhanced oil recovery, this is than asking what are the effects of biosurfactants on enhanced oil recovery. The reason is this: biosurfactants, as many of you already know, it's not just one particular compound. You have hundreds of biosurfactants in existence. It's not just one particular compound or molecule. So it means that you don't have an idea of which biosurfactants you're referring to, because there are probably hundreds of them out there. But if your question is concentration, rhamnolipid is one type of biosurfactant. You are more specific here, you are more generic in the second instance. Same as the case of when you want to ask a question, or if you want to ask a question, like what is the effect of rhamnolipids on all oil-containing compounds? Again, all oil-containing compounds doesn't mean anything. There are thousands of oil-containing compounds. Why not ask a question like, how does the use of rhamnolipids influence its efficiency in EOR? You are being more specific in this case. Again, this is relative. Relative in the sense that it's always difficult to put up a question that is absolutely specific. You like I mentioned previously, you have to adapt your questions as you go by, which is why it is very, very important that you document each question you ask and the outcomes. I'll give an instance. I asked a question. I went to literature. I formulated my question. I went to literature. I identified articles, that I think would be relevant to answering my question. I extracted the results from these articles, compared them with mine and also with other articles, and Again, I found out that I probably asking, I could ask a better question, and I decided to pose another question again, formulate another question, go again to articles, extract results, compare, come back again, formulate a different question, and so on and so forth. The thing there is that if you don't keep track of which questions you ask, what were the outcomes that you obtained, you would get confused at the end of the day, because you may suddenly remember something and you want to go back to it, but because you didn't document properly, everything is lost. So this documentation is key in anything. Whenever you're trying to review literature, it cannot be overemphasized. It's very important. Again, it's a completely adaptive process, which means you don't always get it 100% at the very beginning. You adapt as you go by. Now, in this case, or right now, we have successfully formulated the question we have in mind, formulated a research question, and we are rushing down to database, any specific database. We've gotten some articles that we think would be relevant to answer these questions that we have in mind. So we want to extract, we want to compare their results. But before we do that, we have to know what were the questions that these authors wanted to answer in their work. Why it's very important that you take time to understand the question that the articles or the authors wanted to answer in their study is because if you do find their question, you can determine if the questions that they are asking correlates with the question that you have formulated for yourself. Remember, you had a mission that took you to dive into articles or to dive into publications to extract and compare results. You have to be sure that the mission you have and the mission that these authors have are the same. If they are not the same, it's safe to say you have no business looking at those articles actually. So you want to find the correlation between your question and the research question that was asked in that particular article. Also, when you do this, it will help you to focus only on the most important information in that particular article. Why this is important again is the fact that, as you would know, many articles are almost 35 pages in length. Surely you don't want to keep reading through 35 pages without even knowing if you were supposed to have read that particular article or not. If you also know the kind of question or the research question of this article, you'll be able to assess the relevance, the quality, the outcomes that they tested, and the methods that were used in this particular article. The question now is, how do you find out the research question that was asked or that was answered in that particular article? You could do this in different ways. The most common one is looking for explicit statements. If you're reading an article, you could see some authors clearly mention that the aim of this, so has been done so far. Different research have tried to find out or try to give evidence of these reasons why biosurfactants can be used in enhanced oil recovery. But in our study, we wanted to investigate the effect of concentration on the efficiency of biosurfactants. Safe to say, it simply means they're asking, what is the concentration? What is the effect of concentration on the efficiency of biosurfactants? Statements like this could be explicit if you're lucky. Again, this depends on the quality of the journal, also the expertise, or should I say the prowess, the literary prowess of the authors. Some articles are very easy to comprehend, some others are not. It depends on the quality acceptable by each journal, which varies generally speaking. So in some articles you could find out very study that was conducted. Some other times you have to look at it deep. But if you're looking for explicit statements, you can easily find them in the abstract section of an article or even towards the end of the introductory section. I'm going to show you an example just after now. Also, you can try to find out the aim of the work, which sometimes some authors will use that word, the purpose of this study, or the aim of this study was to XYZ, which you'll see these authors presenting the state of the art in that particular field, and then they try to come in and tell you, in this work, in this work, the effect of XYZ was investigated. So to say, this is what they are trying to answer. They are trying to answer what is the effect of, what does this do, and so on and so forth. I have to point out that you will not see this being put as a question in almost 90%. Literally, you never see this most of the time. But you can already infer what question these authors wanted to answer in their work. And again, the best places to search for this is in the abstract, in an introduction section, especially the concluding paragraph of the introductory section or introduction section in the work. So look out for terms like keywords like investigate, explore, examine, determine, blah, 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 and so on and so forth. This will give you an idea of what questions were asked in that particular study. To give you an instance, I pulled up this article which started in 2019. They are trying to investigate the synergy between the effects of silicon nanoparticles, biosurfactants, and salinity in enhanced oil recovery. And I thought to give an example or to highlight how you can identify the questions in an article. I'm sorry, this might not be very, very clear. I couldn't take a clearer screenshot than this. But if you can, by any chance, read this particular abstract section. So I put here the abstract section of this work and the last paragraph of the introduction on simultaneous flooding and effects on oil recovery. I could almost immediately tell you that the question that was asked in this study is, what is the effect of process parameter on silicon nanoparticles, or on the concentration of silicon nanoparticles and biosurfactants on oil recovery and simultaneous flooding? This is what these guys wanted to answer in this particular article, in this particular study. If you look again at the last paragraph of their introduction, when you read, you see that they try to mention that they try to give, what has been done so far. Whenever you use the word, see the word despite, of course, they're trying to tell you what has been done so far, but what has not been done, and how, again, in their work, what they investigated. You see, again, the appearance of keywords like investigated, explored, determined, like I already showed you in the previous slide. So these are ways you can easily identify what questions were asked in a particular article. And now you're done, you already have an idea of what questions were asked in that particular study. The next thing to see or to check quickly is, what kind of study did these guys do? Or what kind of study did these particular authors, use to answer these questions that they posed already? There are different types of studies from different disciplines. Sometimes study designs are just simulations, case studies, controlled laboratory experiments, or wet lab experiments. Some other times, the study could just be a review of literature. It could even just be a meta-analysis. This meta-analysis is usually the most juicy kind of study people in the medicine and biomedical world like to do. They really love meta-analysis a lot. Or it could even be a mix of any different study designs, actually. It could even be a field study, depending. There are different kinds of study designs that could be used to answer research questions. And it's very important that you find out the specific study design that was used in that particular article or those particular publications that you intend to extract results from and to compare their results. Why this is important is different study designs have their limitations, and so their pros and their cons. Again, if you're going to compare two things, if you're going to compare A and B, you need to make sure that the outcomes that are stated in A and the outcomes that are stated in B were obtained using similar methods, which means similar study design. If you're looking at a work that did a computer simulation and another work that did a wet lab experiment, a wet lab study, and the guys that did these computer simulations are telling you that the best concentration of biosurfactants to use in oil recovery is 10 grams per liter, based on their simulations. The guys that did wet lab experiment are telling you that the best concentration of biosurfactant is 10 grams per liter. So the same thing that is reported in these two cases, computer simulation 10 grams per liter, wet lab experiment 10 grams per liter. And you think that because these two values are the same, therefore it's easy to you can easily compare. Well, that's not going to be a very true representation of reality, because these two results were gotten under totally different conditions. So whether they get the same results or they have differences in their results, it's very important for you to note that they were not obtained under the same conditions. Hence, you have to be very careful in comparing this kind of results. Again, computer simulations have their limitations. Wet lab experiments have their limitations. You need to take note of all of this. This is why it's very important that you pinpoint what study design was used in that particular article or in that particular literature that you're trying to probe. It will also help you to identify potential for bias, just as I just illustrated right now. But again, how would you even identify the study design? It's always pretty simple. If you look at the title or the theme of the paper or the publication, you almost 90% of the cases you can already infer if this was just a literature review or if it was a wet lab experiment or it was a computer simulation. However, even if you don't get the idea from there, you would see, again, in the title section, you will see people telling you things like a literature review on or a review on and so on and so forth, or when they are done, they write a review. So it's very easy to see this many other times. Even if you don't find this answer of what kind of study is the abstract or the end of the introduction section or the materials and methods, you can already figure out what study design was used. It's always very important that authors mention this, so it's not something hidden. You can easily figure this out. And again, just to give another example here. So I put up an article. I think it's the same article like I showed you previously. The same previous article I showed the introduction. Well, don't worry yourself about reading it, but good luck if you want to read it. You will see that they mention the method or the study design that they used to answer their research question, but it's not very clear. It's written in a lot of complex sentence. And if you're not careful, you may get confused about what study design was used. However, if you quickly go to the materials and methods section, by seeing some kind of words like NIPs were synthesized, as a chemist, you know that if somebody says were synthesized, it means this person did a wet lab experiment. It's almost the case many a times, I forgot to also mention that you may not only see only one study design that is used in a particular article or publication. They could use a mix, it depends. So you have to be careful that you identify the study design or the study designs that were used in that particular publication. It's always easy if you go to the materials and methods section instead of the last paragraph of the introduction. However, you can find this answer in these two areas. And now, so far we've talked about the importance of identifying research questions in an article, understanding the study designs that they've used. But let's now see, how to identify, the outcomes and how to actually extract results. And let's think about this extract like as if you want to mine something. So I think for people in the data science field, they'll tell you mine data. So you want to mine the results in a particular, literature. So the first question is, how do you extract results or how do you identify outcomes? Well, it's very easy. Outcomes or results in this case refer to tables and figures and illustrations, which you would easily see. So when I say tables, figures, it could even be images, it could be micrographs, it could be seismographs, and so on and so forth. It depends on the particular field, it depends on your academic discipline, it depends also on the publication you're looking at, what kind of results do they present. Results vary actually, so you need to understand. But however, results are generally presented as tables, figures, illustrations, so you could easily figure this out. It's very, very visible even to the blind. However, in many cases, not many cases, in some cases, results are not always presented as tables and figures. They could actually just be statements. Statements, I'm referring to sometimes when you might be reading a particular article and they'll tell you, they'll tell you that 10 grams per liter of biosurfactant was obtained as the optimum concentration for the oil recovery. They put in brackets information or results not shown here, which means they could have put it either as supporting information and published the supporting information, or They just had it as a side information for themselves, and these authors did not publish this extra information. So it's important that you keep in mind that results are not always tables, figures, equations, and so on. They could also be statements. So it's important that you be on the lookout for this, actually. And you could see this kind of statement either in the abstract, or in the results and the discussion sections, even in the materials and methods. Before you even start looking for what results that you want to pick out, it's even important for you to find out if this particular analysis or this particular procedure was done before you even obtain results. Because anything not presented in materials and methods many a times will not be presented in the results and discussion. You only present results and discuss that you've already informed your audience that you obtained and how you obtained it. Now, why this looks like a very simple process to just extract results, it's very important for you to know that the method of presenting results in articles vary greatly by the quality of the journal, by even the editorial guide or the author's guide by each particular journal. It could also even vary by the expertise of the authors. For instance, some persons are very much used to presenting results as graphs, bar charts, put bar chart, probably put the standard deviation, represent your bar charts as mean plus standard deviation. Some persons may not present some statistical results alongside this particular bar charts, And this is why I said there is always heterogeneity in result presentation. It's never organized manner. You could create a database, a very simple Excel sheet to even do. Always make sure that you organize these results for easy reference, because sometimes you finish extracting results and you don't know where they went today. Everything just disappears. So organization is always key. In every step of review of literature, organization cannot be overemphasized. If not, you end up wasting your time. Pay attention to the kind of results you're looking for. Are you looking for quantitative results or qualitative results? This is something you have to determine before you start looking at the results that you want to extract. And don't forget to always check this supporting information section of articles. Yeah, a good number of articles always include supporting information. Some other times they don't. If you feel that you don't see a particular result in an article, or you think it should be there, but probably the authors didn't present it, you could easily reach out to them. They always have the corresponding author's email, which is always put at the top or at the bottom of every article. So you could easily send them an email, and probably if they are very kind enough, they could send you this missing result. So far we have talked about the first 3 steps of reviewing literature. We just finished talking about how to extract the results and where you can find these results. Now, moving on, we have to talk about now the main deal, like comparing. I like this particular part of comparing results because it's a very tricky process, comparing mango and apple. Many times that's what we do. We want to compare apple and apple, but we end up comparing apple and mango. But before you start comparing results from different publications, there are some considerations, or there are some criteria, or some things you should be very much aware of. Number 1, if you're looking at a result from article A and another result from article B, and these 2 results are maybe on the emulsification index of biosurfactants. Let's say, for instance, you want to see, maybe your question is, what's the best concentration of biosurfactants that will give you the best emulsification index, for instance. You have to check that the effects that you're comparing are actually similar or different. You have to also check the magnitude of the difference that you obtain, which means if article A says that 10 grams per liter was the best concentration, article B says, oh, it's not 10 grams per liter, it's actually 20 grams per liter for the same biosurfactant. You now see that there is a difference in their results, which is not a problem actually. You should have this divergence. But the question is, what is the magnitude of the difference of these 2 results? Are they far apart each other? And this is always a very big problem, because most times when you do wet lab, when you do some experiments, you don't obtain the same results as what other people obtain. And you begin to get very much frustrated. But instead of looking at the absolute value of what they obtain in their results, why not consider what is the degree of the difference in my own measurement or in my own results and their own results, or in the results of Article A and the results of Article B. If you have this in mind, you may be able to standardize. You may, emphasis on may, it doesn't work in all the cases. Another thing you have to put in mind while comparing results is, did these guys present any statistical significance? That is, it depends. You don't have statistical significance for all the different types of results. You only have statistical significance if you are dealing with quantitative results or quantitative data. If it's things like micrograph or microscopy images, of course, you know that's not possible. So if these are quantitative data, you may want to consider the statistical significance of the results. You look at the kind of deviation, the standard deviation that they presented. If the standard deviations are high in Article A, you can almost imagine that even if you have a difference in the results in Article B, maybe it might be accounted for by the high standard deviation, or the error of the mean that was initially indicated. Again, when you're looking at results, first things you look at are, what is the pattern? Is something increasing or is something decreasing? As you increase a particular intervention or effect, what is the outcome? If you increase concentration, does emulsification decrease? If you decrease concentration, does emulsification increase? Vice versa. You have to look at the pattern and of the two results that you are trying to compare. Are they similar? Are they different? What would be the subtle difference if the difference is subtle? What would be responsible for the large difference? You must also make sure that you have a good or a fundamental knowledge of that field, or else you cannot compare. You can't, according to Governor Wike of Rivers State, you say if you did it there, you did it there. If you don't know what these results are, there's no way you can compare it. It's not possible. But when you're comparing results, please, it's very important that you don't overinterpret the results, and you also have to consider the different limitations and biases presented by the different authors in their work. Some authors are kind enough to mention what are possible limitations, in the results that they got, and so it's more like warning you to be very careful. If you look at the results we have, but don't forget we could not do this and this. So put that in mind. Now, that doesn't mean that you should discard such results. No, not at all. You don't discard the results simply because there was a limitation. In my opinion, you should keep these results and keep the limitation that you identified. It could also help you to inform a future research project. It could also help you too, because no data is never useless. No matter how bad the data is, no data is actually useless. Every data is useful. It depends on who is using it and how you want to use it. So in my opinion, keep all results that you obtain, take note of the biases that was mentioned or that you identified, and the limitations, of course, that could have impacted the observations or the patterns you saw in such results. It's very important you do this. And of course, comparing results is very tricky. It's not the most fantastic thing you would want to do, because it requires a lot of expertise. Even professors trying to compare their own results to other people's results would always have to bring in a very good level of knowledge of that field, or else we could get completely lost. Because why I said it requires expertise is, like I mentioned before, some persons use different SI units in their presentation of results. Some other persons, instead of using bar chart, could use a box plot, and so on and so forth. If you don't know what kind of results or how these results should be presented, you may completely get lost. Different conventions that could be used, and these things are always updated. You could see that maybe 10 years ago, bar charts were the most fancy thing. These days, people who prefer box and whisker plots, and so on and so forth. So this is where you have to bring in your expertise, and you always have to make sure that you're updating yourself, and don't hesitate to stop and do an exploratory literature review, or go read further on that particular subject if you need to. Like I mentioned, this is a completely iterative process. It's never linear. You don't stop. You don't start and stop. It's not a straight line. So But another challenge you're going to encounter in comparing results is publication bias. Like I mentioned to you, different articles or different publications or different journals have different standards of what they accept. And even different authors are actually skilled in different ways. So this is a very, very big issue in results presentation, publication bias. Um, some journals could accept a low quality article and publish it. Some other journals will reject it. So you now have the problem of, because they said this article was peer reviewed doesn't mean that the quality is absolute actually. So how do you now compare these results in this article with yours or with other articles? You have to consider this. Like I mentioned, the fact that there is a bias doesn't mean you should trash your results. It simply means you should keep it, but take note of the bias. It will be useful when you are trying to generate ideas from your comparison. And of course, very, very important, as you compare and you contrast and you draw conclusions or you generate ideas, it's very important you also document. I can't overemphasize this very much because sometimes you just want to keep opening different tabs on your browser and in your mind, just making sure you don't close the tab is enough for you to quickly come back. It's not true. You could have your browser crash. Your browser could actually crash and you lose almost 2 months work, 3 months work, 1 week work, even if it's a day work, you lose time. So it's very important that you document effectively, organize all the results you obtain, and also, like I mentioned, don't always overinterpret. It's very important. Stay focused, and the best way to avoid overinterpreting is define your own or to formulate your own research question, to identify the research question in a particular article. If you do this, it will help you to stay focused. Like I mentioned, you don't have to read through all the pages of that article to get what you're looking for. Don't forget to apply the different reading techniques, skimming, scanning, and so on. Determine what's best for you to use. You don't have to read 25 pages of articles before or 30 articles or 30 pages before you find what you're looking for, which is why it's very important you don't be a scalar quantity. Now, we've talked about how to compare these results, the take note of the limitations in the comparison, and I thought maybe we could take a very, a quick look at the case study. I thought might be very interesting for us. So, the question we asked, let's say for instance, we want to investigate the relationship between the emulsification index and the concentration of rhamnolipids. Our question is, what is the relationship between E24 and concentration of rhamnolipids? Let's now say, for instance, we decide to delve into literature, and I present to you these two articles written by Sharma et al. In 2018 and Kamara et al. In 2019 as well. So the both of them actually studied rhamnolipids and the application in microbial enhanced oil recovery, same as these guys too. So, well, they put rhamnolipid biosurfactants, rhamnolipid actually. And they were produced by the same microorganisms, Pseudomonas aeruginosa. Forget about this details anyway. Now, I went straight to what I am interested in. Don't forget this particular publication, if you go through it, there are probably 20 different graphs and tables and charts that they have there. But I'm not interested in everything. My question is very specific. I'm interested in the E24. And I have gone and I found out the representative. I've read the abstract and found that they also want to answer this same question, that their own question that they identified is what is the relationship between E24 and concentration? This is the same question that they want to answer. So first things first, my question aligns with their own question, so I can go ahead and compare. Now, I found the result of their E24 here for these guys. Please pay attention to only the blue chart here, which is for crude oil, because the oil that was used here was, in this particular study, they used different oils or different compounds, but here they used only crude oil. So I had to find out what's the similarity between these two. So crude oil and crude oil. So that's why I have to put this arrow here for you to focus only on this graph, please. Now, they used a 2.65 grams per liter of rhamnolipid on crude oil to determine the emulsification index. Meanwhile, these guys actually investigated the relationship between the different concentration of the biosurfactant and the E24 that was obtained accordingly. Two different approaches, anyways. These guys used only one concentration. This one want to know how concentration influences. And what I found is, okay, so these guys reported that if you use a 2.65 gram per liter of your rhamnoliquid, you will have almost a 70% E24. Okay, so let's look at what 2.65 grams per liter means. These guys here did not present their results as gram per liter. They presented it as milligram per liter. If you don't take note of this difference in the SI unit and you want to quickly compare in your mind, these guys use 2.65. These ones are using 200, 300. It doesn't make any sense. But the reason it didn't make sense to you is because you probably forgot to look at the SI unit that was used to express. These values into grams per liter. If you do so, you will find out that at this saying that 2.65 gram per liter is probably, somewhere around here, as the case may be, or somewhere around here. And this corresponds to almost 70% in the E24 identified by this study. These guys also identify 70%. Probably in my own study, I identified maybe 60%. So first of all, I've been able to see that there is a direction here. These guys have given me an idea of the variation of concentration with E24. These guys did not give me that information, but I have been able to compare and contrast these two, that they did not obtain probably exactly the same result, or they did. One thing you will see here is that this study here did not present any error bar, so which means that they probably did only one replicate. You have to take note of this. This is an important limitation. If you don't do replicates, you reduce your degree of freedom. Statistical significance probably is very low. Same thing in these guys. So I have to note that I compared the evidence or the results of these two studies, but look at the limitations. They each did not present the statistical significance of their results. They also used probably two different rhamnolipids synthesized in two different ways, and so on and so forth. There are many things that you can figure out, and then you have to ask yourself the question, are these two results actually comparable? Can you compare it? Of course, there are different answers to this. It depends on you. It depends on your expertise in this field. It depends on how relevant the information you get from the comparison will be to your own study, and so on and so forth. It's completely up to you. But you have to make sure you take note of the limitations and the biases during your comparison. And an AI that could help you answer your research question. If you put your research question in consensus.ai on the consensus platform, it's not going to synthesize an answer for you like ChatGPT, you will see shortly. What consensus will do for you is that it's going to also look out for articles that have similar questions like you. So it's going to help you in that step of identifying your research, or formulating a research question, and also identifying research questions in articles. If you use consensus, it would really save you a lot of time in this regard. Please take note, the fact that you put in a search keyword or you put your research questions there, and it brings up some results, doesn't mean that those results are exhaustive. AI is not perfect. All the AI tools I'm presenting to you here, actually many of them are still undergoing a lot of development. So please pay attention. That's why I have to emphasize that you should use AI responsibly, which means don't leave all the job for AI. AI is only there to facilitate, which means you must also know your onions before you consult AI. So you also have sites.ai. Sites.ai will help you to prove if you cite an article. The fact that an article has 1,000 citations doesn't mean everybody that cited that will agrees with it. Some persons agree, some persons don't agree. It could help you to make sense when you're comparing results from that article with results from another article. Site.ai can give you a breakdown of the number of articles that agree with that article, agree with the submissions of that particular article, the different number of articles that also disagree, and so on and so forth. ChatGPT, of course, it's something that's been trending for a long time now. GPT can help you to synthesize. It can crunch data information from you from the internet, synthesize all the information for you, and it saves you the stress of having to read or pour through tons on tons and tons of articles. You could easily ask GPT what is the best concentration of raminolipids in oil recovery. GPT would try to read up articles quickly that have reported this particular study and give you an average value or representation of what people have reported. However, it makes a lot of mistakes and it should never be trusted, even 80%. You can just simply leverage on it as a step one or as a baseline for your investigations. Elicit.org is really very interesting. So you could use elicit.org to brainstorm on an article. You could present an article to it. It could actually brainstorm on the key findings in that particular article and give you a summary. Same as Microsoft Bing and Insightful, and there are so many AI tools that you could use out there that you could use to expedite your literature review process. Now, so far we've been talking about why it's important for you to extract, compare results. We said you could use this to inform a research project, identify research gaps, most importantly, answer a specific research question. Don't forget your question has to be really specific. And we said that there are different steps in reviewing literature. You have to identify research questions in that article, define the study design that was used, identify what they measured, the results they presented before you compare the results, and don't forget to always note the biases and limitations that were identified. And of course, this cannot be overemphasized, that for you to do all of this successfully, you would have to have very good knowledge, or very good is subjective, it depends on you. Expertise, scientific expertise is very important in an article. Don't hesitate to contact the corresponding authors in that regard, or or any of the authors if you can find their contact information. And of course, don't forget to take note that sometimes results are presented, but there are other factors that were considered in the process of obtaining those particular results. And again, just know that you only get better in extracting and comparing results as you do this more often. So of course, it's not again saying that practice makes perfect. And with this, I would really like to thank you very much for your attention. And please don't hesitate to reach out by LinkedIn, email, as the case may be. I'll be very happy to speak with you if you have any questions that perhaps we can't answer now. And I would like to take the time to also thank the organizers of this session for your kind invitation, especially Dr. Vivian. Thank you very much. And I'm very happy to take your questions if you have any.
Okay, thank you so much, Mr. Victor. That was a very deep learning section. Yeah, on how to really extract and compare information from published articles. So, Blessing raised her hand initially. I don't know if Blessing, are you still there? Do you still want to ask your question? So please, if you have any question, you can raise your hand so that you can unmute yourself and ask directly to the presenter, or you can drop your question on the chat box. So while we are waiting for questions, I would like to specifically thank you, Mr. Victor, because this is a really great work. Like, comparing, although you said we grow, right? Maybe as undergraduates we might not be as detailed or thorough. I've never heard about it this way, how thorough it should be, right? So, and I want to thank you, because maybe myself will be making mistake in most of my reviews, not even looking at the SI units and all those things. I don't even know that sometimes statistics are important, like statistical analysis are important in even literature reviews. So you really brought those things out. Thank you so much. And there are things that you, sorry, let me just ask first. when you were talking about mind map, the first one,
Yeah.
I did not actually get what you said. I'm
Okay.
sorry to draw you back.
Okay. Sure. I could explain again maybe about this mind map. So, like I mentioned, first of all, let me ask you: do you like investigative movies, like crime scenes and so on?
Yes, yes, yes.
Right. Okay, so I'm sure you often see the policeman or whoever is investigating a particular crime or situation. You always see them pinning pictures or statements or post-it cards or papers on the wall, and they are always trying to find the link between event A and event B. Now, this is the same thing you should actually do if you are carrying out review of literature. Because don't forget, you're probably reading 10 or 100 different articles, and you have one goal. Your goal or your objective from the very get-go was to compare the results that these guys have presented. So it's very important that, for instance, maybe in blue, sorry, not blue, purple, if you could, let me get the pointer, 1 second. So if you could just imagine in purple here, in purple here could be the research question that you want to answer. That is, you formulated your own research question. To give an instance, what is the effect of temperature on the efficiency of biosurfactants? For instance, this is just an instance. This is your research questions. You've consulted the first article. Let's say the first article is in green, and you are very much interested in the E24, the emulsification index of this biosurfactant. So you're looking for articles that actually presented this efficiency in terms of emulsification index. You've read article A, you've got their results. Their results could be these other tiny circles that you see. So you read article A, and these are the findings you got from article A. You write it down. You come to article B, you do the same, C, D, E, and F, and so on and so forth. At the end of the day, you can have a global view of all the results you've obtained. Don't forget, the essence of doing this activity is not just only to compare different results, but it's for you to get ideas. Because if you look at the theme of the research of this evening, is compare results and ideas and get ideas. If you compare results, the final goal or the end process is for you to learn something from this. And the only way you can learn it is if you're able to connect everything together. If you read 100 articles, there should be a relationship between everything that you've learned. Even if there is no relationship, the divergence, you could see that here when you create a mind map. Now, you can create a mind map with your pen and paper actually. I do that. Sometimes you don't have to use digital or tools or software. You can simply draw on your paper and pen, but of course it's very traditional and you can imagine you waste a lot of time. So that's why I recommend that you use tools like Miro. Miro app can actually help you do this. Let me see if I can quickly show you an illustration here. 1 second. Okay, so I have to share my screen. In this case. Okay, so I was trying to show you could use this app called Miro. It's a free mind mapping tool you could use online. Although it's not completely free, but you have some free trials that I think you have a lot of opportunities to use it for free before you are either asked to pay or so on and so forth. And it's very easy. For instance, if I look at the platform, this particular study here, I'm looking at E24, and that's the emulsification index, and biosurfactant. And I understand that these guys are trying to see the variation in the emulsification index as they increase the biosurfactant. So this is the effect, this is their response. But you see also that these guys also plotted surface tension, ST, on the other side of the graph, on the right y-axis. Now, by looking at this particular graph, I may be so tempted to see or to find the relationship between surface tension and emulsification index simply because they put them in one particular view. right? But I'm not interested in surface tension. Surface tension is probably out of the limit for me now. It's out of scope for me. I'm just interested in emulsification index. And this is why I would have to focus only on this and not interpret the variation in emulsification index and also start interpreting that of surface tension. You will be getting too many ideas. And like I said, you could almost spend a whole day just trying to interpret the findings of a particular article. And of course, that depends on if you have that, that amount of time to spare on one place. Again, when you over-interpret, you may lose focus. It's always the case many a times. I have one question here. The question is, if you increase concentration, what do you have as a multiplication index? And I have this, or I have that this is a non-linear variation, which means it's linear at some point and becomes non-linear at another point. That is it. It's that simple. Pick it out as your observation. If you try to go further, maybe as you read their results and discussion section, you see them making some other very interesting points. Everything is always very interesting. That's the funny thing in reading articles. If you're very curious, you'll find that everything is too interesting to you, and you are trying to make sense of every single statement that these guys are making, because it's indeed fantastic to read, but you must have to stay in line. So don't always overinterpret. And when they say A is A, take A as A. However, we know that there are other factors responsible for A being A. Write them down. Just put them one side, like take note of them, but don't focus too much on that. You will focus on them when you've gotten all your information, everything you're done comparing and contrasting, and now you want to get ideas. In that particular stage, it will be relevant for you. But when you are actively comparing results, please stay in line, or else you may lose a lot of time. I don't know if that answers your question, Joy.
Yes, it does. Thank you very much, sir.
Okay. You're welcome.
Thank you very much, Mr. Victor, for that answer. And thank you, Joy, for asking that question, because he's been emphasizing on do not overinterpret, and it's something that happens to me most times. I don't know if it happens to every other researcher. When you're looking for one particular information and then you get chewed by another information and you want to focus on it. So thank you so much for emphasizing that. Yeah. So I don't know if we have other questions, because for me, I think you really did a great job. You explained everything in details. Yes. So I think that is why people are just thanking and thanking you. We really do not have much questions at this point. But I'm sure that in the course of our research, because we have a research community, so we have a lot of things that we are doing, and I'm glad that you shared your contacts. Personally, I've sent you an invitation on LinkedIn. Yeah, so we'll be sure to reach out to you if we have any further questions or encounter any other difficulties in the course of our research. And I also noticed that you mentioned some things like the referencing tools and all those things. So thank you so much, Mr. Victor, and I want to thank everyone for attending the Geohorizon and SEG-NAU Research Community Open section on how to extract and compare results from published articles. So, Mrs. Vivian, do you want to say a few words before we wrap it up?
Okay, I want to thank everybody who stayed till the very end, and for those who are unable to do that because of one activity or the other, thank you for stopping by. Emeritus Victor Ibupe, thank you for gracing us with your knowledge and presence today. It was really insightful, I tell you. I think, yeah, I'm a doctor, but I still learned a couple of things. Why I not consult you now? Life would have been easier. Thank you for helping my students and for some other persons that came from different aspects. I can see my very good friend here, Dr. Kevin Ehioso, my very good friend. Yeah, he's actually working with some French institute right now for his postdoc in Paris. I think we have a lot of strong personnel here, and I'm really glad that you guys are here with us. I think one of these days we will invite Dr. Kevin. He has a lot of knowledge in his head that he can, try to transfer to us as well, just like Victor just did. Thank you, guys. I think I'm going to see you guys in the research community this week. But other than that, let's have a great weekend and have a lot of fun too. Thank you for being here again. Bye.
Thank you very much. Have a good evening.
Okay, thank you so much, Mrs. Vivian, for that. So please, thank you again, and please respond to the webinar follow-up email. Let us know what you liked, what could be done better, and suggestions for future webinar topics. And also look out on our social media pages for adverts on our future events and register for them. So again, I would like to thank you all for attending today, and thank you very much, Mr. Victor Ibokwe, for pouring out such a great amount of knowledge to us today. Thank you so much, and do enjoy the rest of your evening or morning or afternoon from wherever you are. Thank you.
Excuse me. Thank you, Chinaza. Thank you.
Bye.